This is part 6 of the rates and equilibrium topic in the AQA GCSE chemistry course. This is a dual and triple award topic, so everybody taking this course does need to be familiar with what we're about to look at. I'm going to recommend you pause and try each activity as you go. In this video, we're going to introduce reversible reactions and work out and show how we represent them. We'll also look at a couple of examples as we go, but have a think about this question to begin. So on here, A and B can react to make C and D, but C and D can also react backwards to go to A and B. Now, it does seem better to have a more efficient method than writing both of those equations together. And the way we do that is to use this double arrow. You can see there's half an arrowhead going forward, half an arrowhead going backwards, and that is our reversible reaction symbol. So have a go at sketching it out, make sure that you're happy to do it. And it looks like this. Let's take an example of a reversible reaction, and that would be the addition of an acid to an alkali and an alkali to an acid. And we can use an indicator to show whether something is acidic or alkali. And you do need to remember these facts as well. What would the colour of litmus solution be in acid? It would be red. What's the colour of litmus paper in alkali? So I've taken my acid and I've added an excess of alkali to it. It has become alkali. And in that circumstance, it goes blue. And then if I then pour a lot more acid into it and it neutralises it and goes beyond neutralisation, I make an acid again and it goes red. And I could carry on doing that from red to blue to red to blue. What do I need to add to this equation to show what's happening when I do this reaction? And you're seeing there is a theme here. There's not a great deal to think about. It's the reversible reaction symbol. Taking a look at the second example here, ammonium chloride. I can take solid ammonium chloride, a white solid. I add a cotton wool plug. I can then heat it strongly over a Bunsen burner. And then we look at what happens while we're heating it, but also what happens after you've heated it. What do you see in this reaction? Well, the first thing you'll see is that the white solid vaporizes. It turns into two colourless gases. You might get some smell. Ammonia has a very pungent aroma. The HCl wouldn't have a smell, but it would be another colourless gas in there. But we might get the ammonia smell. And then once it cools, the white solid reforms. Why did we add the cotton wool? Well, in a sense, we've got a solid at the bottom of the test tube. We're heating it. We don't want to lose any of those reactants. The cotton wool's not going to stop the gases. They will escape through, but they'll escape more slowly than if it wasn't there. But ultimately, it's to prevent the loss of solid reactants, any spitting of those reactants that could be dangerous to those people around it. The reaction shows the decomposition of ammonium chloride to ammonia and chlorine. And we've seen the reverse of that too. What would the equation look like? So that's actually ammonia and HCl. Now you do need to be familiar with the formula of ammonia. You've seen that in the bonding topic. You'll see it in the Haber process topic and in later videos here. The equation, well, we start off with NH4Cl, which is solid. The reversible equation, and we're making NH3, which is a gas, and HCl, which is a gas. And we have got here the white solid and the colourless gases. This is the most important thing to take from the video, that the reversible reaction is used in reversible reactions. That takes us to the end of this video. Thank you for listening and goodbye.